In this episode we're going to be playing with some servos. However, before I begin the video, I'd just like to give a big shout out to P40F20, Love Minis, Chris Campling, Andy Clift, Alan Allsop, Chris Davies, David Trapp, Fleetwood J, Duncan Price and Trevor Rodway. Thank you very much for commenting on my video. So hello, hope you've all had a very good week. Now I have run into a little problem. As I explained last week, I did actually run out of silver filament, so the two pieces that I wanted to reprint I wasn't able to do. Now I did also explain that I'm actually making videos in advance so that I can release them once a week, and should I run into a problem I won't be delaying the video. So this is actually being made just after episode 2 has been released, so please forgive me. I still haven't had time to get the silver filament in, so I'm not going to be able to do the dome this week. It's not a major problem, because what I'll do instead is I'll bring in something that I had planned for a future episode, and we'll just do that today, and that's going to be playing with some servo motors. Now this is a servo motor. I will go into more detail a little bit later on, and I'll explain why we're going to need those. Now what we're going to do first of all, normally we'll be printing stuff off to use, but obviously we're not going to use it this week, but we'll get it printed anyway. And what we're going to do is we're going to first of all finish off the lower dome rings. Okay, so these are our lower dome rings. They're pieces 6 and 7, as you can see. They're written on the bottom. To be honest with you, it's not really anything that we haven't seen already, so I'll just go quickly through them. 0.3 layer height, just a 10% infill. There shouldn't be any supports needed, and the rest of the settings really are up to you. I like to use a brim. And that should take about 5 hours and 4 minutes, maybe a little bit longer. Really depends on the actual printer. Okay, so these are the pieces that are done. I'm showing you in this camera because I'm going to put them onto the rest of the ring. But again, exactly the same as we've done the last couple of weeks. Nice little quality. It doesn't need to be perfect because it's going to need a sand regardless of the quality that we use. Now they both pretty much look the same in that they've got these sunken holes, but occasionally you'll see a little hole there, and it will all make sense once we put it together. So 6 and 7, and then what we'll do is we'll get our ring that we've already assembled. So obviously 6 is going to go next to 5, so that goes into there. And the one that's always the most trouble for me is the last piece, because obviously the last piece connects up to the previous piece plus the first piece, but in actual fact that's gone in fine. So this is R2D2's lower dome ring. Now if we put it with the dome, this obviously isn't, there's a piece missing. There's the blue rim in the middle, but that's basically what it now looks like. So it's gone from that to that, and then in about 2 or 3 weeks we'll have a little gap in the middle, and that will be blue. So I'm very happy with that. Now you can see that you might need a closer look, but you'll get to see a look. So there is equidistant holes all the way around. These are the sunken holes. Now those holes will line up with the holes that you see on the bottom of the dome. So there's roughly 2, sometimes 3 per dome piece, and let's say they will line up. I don't think it's going to matter which hole goes in where, because it does all look absolutely identical. Now the holes that you see on the inside, the holes that aren't sunken, you can see one there, one there, and so on and so forth. I believe that that's going to be where the Lazy Susan's going to go, so it'll go into there. I may be wrong, I haven't investigated all of the STL files yet, but I believe that's how it's going to work. So let's, shall we have a play with some electronics? Okay, so when we've completed, sorry, I've got the wrong dome, I do apologise. Right, so this is the dome pie from the top of the R2D2. Now you'll see that there's 6 sections here, and obviously that will go on to the dome. So you'll see there that each one's got kind of a what do you call it, a square. It's got 4 sides, but one side, the parallel sides are longer. Anyway, so each of these will have a panel, and what will happen if you want it to do anything, that panel needs to open and then something will come out. Now it's still in, like all good projects, this is a dynamic project and it's always going to evolve. Now I've said that at the very least I'm going to build a static R2D2, an R2D2 that will just sit there. It's nicely painted but doesn't do anything. That's fine, but I want it to do something, and I want it to do the D'Agostini features absolute minimum. However, there's one feature I don't know if it features in the D'Agostini, and I actually found it this morning at time of recording, and that is the zapper. That's my favourite bit. So yeah, that's it. If my R2 only has that bit, I would be happy. Obviously the zapper bit's going to be quite dangerous, but if I can just have that point poking out the top, then that would be superb. So what's going to happen is we're going to need an Arduino or some kind of electrical device controller to open up the panels, and things are going to have to come up. There will most likely be a life scanner, there will be a periscope. I've still got to research the rest of the dome pieces. I can't figure out what's in them, but for what I understand is that if something comes out of a particular place in the film, that has to be there. You can't put something that isn't there. But if, for example, there's one particular dome piece where it just never features in the show, then that opens it up to put whatever you want in. So for example, I could have a sweet dispenser if I wanted, or a cigar dispenser. I could have R2 go, you know. Okay, so what we're going to look at today is the Arduino. Now I have trouble switching between screens, so as I'm going to do most of the work on this screen, I'll describe everything here. Now what an Arduino is basically it's a piece of circuit board with various chips and sockets and all sorts, and that will then control what we want something to do. So in this case we're going to operate a servo, and because the servo is going to operate our in this particular case our dome openings. So this obviously everything you do on an Arduino, it needs some kind of code. Now the code will tell the Arduino what to do, when to do it, how fast to do it, what kind of frequency, anything you really want. Now most codes are available because Arduino is an open source project, and what open source basically means is that anybody can use it for free, which is obviously very useful. That makes it a very powerful learning tool, because what we can do, we can take something that somebody else has produced and then adapt it, learn from it, and make it suitable for our own needs. So this is what's called a sketch, and this is found on arduino.cc, and this sketch is called sweep. And what this does, it sweeps the shaft of the RC servo motor back and forth across 180 degrees. what we actually need is an Arduino, a servo motor and some hookup wires. Servo motors have three wires: power, ground and signal. The power wire is typically red, blah blah blah, and tells you how to wire up. Now most of these sketches, they do give you a schematic, and that's um, very electrical, very, if you understand electrics you'll understand that. But they usually also give you a picture, which makes things so much easier to explain, to understand. And then there's a piece of code here. Now, all code, anything that starts with a forward slash or double slash, they're just notes. So you see here that this is called Sweep, and it's by Barragan. This example code is in the public domain, modified in 2013 by Scott Fitzgerald. And if you're going to modify anything, it's kind of common courtesy to not remove that name unless you've completely rewritten the code. Now, I will confess at this point I don't understand all of this code. However, as you'll see here, there tends to be a comment afterwards that tells you what it does. So, servo my servo, create servo object to control a servo. So that must be giving it a name. And you can actually control 12 servo objects on one board. So that's quite useful. You have a variable to store the servo position, and then setup tends to be like, what it basically means is forget everything you already know. This is what you know now. So what we're doing is we're attaching the servo on pin 9. That means that any signals that we send have to come from pin 9. And then we have a loop, and what a loop basically does is it just goes through that. As soon as it gets to the beginning, it goes back to the start again. So we will copy that code, and then we will set up the servo. If there's any new words involved there, you can actually click on these links and that will tell you what they mean. Okay, so this is our Arduino, this is our server, and what we've got is we've popped one of the little, they usually come like this with a bag full of various different bits. I'm just going to put this bit on. Obviously we want to see the results, we should see this move. We've got the wires on the end, and then we will need 3 jumper wires. Now, when we do this on an Arduino like this, what the breadboard is for is so that we can practice, so that we can plug it all in. So let's say, for example, I'm deliberately doing this wrong, but let's say I plug it in like so, and there you can see nothing's happening. So something's not right there. So if I need to correct it, I can just plug that into something, and so on and so forth. If I'd have actually soldered all of that and then found out it went wrong, it didn't work, there's an awful lot of work that I've got to undo. So this is like writing in pencil, and then I will rewrite it by soldering it on a circuit board at a late stage, and that's like writing in pen. Okay, so we're going to follow the diagram, and what we need to do is, first of all, we're going to plug the power wire, which is generally in red, which is going to be that middle one. I'm just a coincidence that this one is the same colour, and this is going to go into the 5-volt pin, which is this one there. I apologise if you can't see. Now, the ground wire is typically black or brown. In this case it's brown, it's this one on the end, and this one needs to go into the ground socket, which is there. Now at this point nothing's happening. It's been powered up, but nothing's happening because it's not been told what to do, and that's where the 3rd pin comes in, which in this case is the orange one. But it could be yellow or white, and that's going to be connected to pin number 9. And the reason it's going to be pin number 9 is that's the pin we're going to tell it to go to. we could equally just do pin number 10 or anything else. So once we've plugged that in, we now need to give it some code, because it doesn't know what to do because we haven't told it to do. And if you remember, we had some code earlier on. Okay, so this is our Arduino software, and this enables us to make sketches. So what I'm going to do is I'm going to paste the code that we put in earlier on, and we're going to have a very quick look at it. So there is pin number 9, which if I changed that number 9 to say 10, then obviously we'd have to put the orange wire into pin 10 instead. And what this is going to do is it's going to move it from position 0 to position 18. 180, so it's going to go from 0 degrees to 180 degrees. It then tells the servo to go to position, so it's going to go to position 0, and then it's going to go to 180. Then it's going to wait 15 milliseconds for it to reach that position. Then it's going to go from 180 degrees, so it's basically going to go back, and that's it. That's all the code is. And I say all of this has been written for us. So if you just use this code and put it in, that's fine. That's absolutely fine. You don't necessarily learn anything from it, and you've still given the credit to the author, which is only fair. But I think it's a little bit better if we just study the code and try to learn from it. So we click on this tick button there that says verify. And what that does, it checks the code for you. So if I've typed something, in fact what I'll do, once it's compiled, my computer seems to be having problems at the moment. It's taking a long time. I think that's almost there. Oh, it's not going to happen today, is it? Right, so there we go. That tells us that the code is correct. So let's say, for example, I'd accidentally put a letter in there, and then when we verify it, it should tell us that there's a problem, and it should tell us, it doesn't tell you how to fix the problem, it just tells you that there is a problem and where the problem is. So there we are. Exit status 1. Error compiling for board Arduino Genuino Uno. Okay, in this particular case, it's not liking that. So I think it's more if you use an actual command. So it might say, hopefully, this is the thing. When I've made accidental errors in the past, there we go. So vvoid does not name a type. So that you see there's a big pink line, so I go, oh, I accidentally put the F in. So let's take the F out and let's re-verify that again, which obviously we know it's going to work this time because we have verified it, but it doesn't hurt to verify it again. There we go, everything's absolutely okie dokie there. So then we click the next button that says upload, and what that will do, provided you've got your Arduino connected to the PC, that will send that code to the Arduino, and that should take roughly about as long as it takes to verify, perhaps a few nanoseconds longer. So there we go, that code is now uploaded. Okay, so this is the moment of truth. As you see, I've disconnected one of the pins, so as soon as I plug this in, hopefully this will work. Oh, there we go, look. And there we go, we've got it going from that position. That's, as far as this is concerned, that's 0 there. And it moves around to 180 degrees, and then it moves back. Let me just move the Arduino out so that we get a better contrast. So what we're going to do next then is we will have a little fiddle with the code, and we can just see if we can just alter that slightly. Okay guys, so I do apologise, I've had to do a record of voiceover on this because it turns out I recorded all of this with the mute button on, which is something I do quite often. So what I'm doing here is I'm having a look at the code, I'm looking at what I can modify, I'm going to try and learn from it, and because I'm going to edit the code, I'm actually going to put my name on it, but I'm going to put as modified. So what we have here is we're looking at the position. We're changing the position to 90 degrees rather than 180 degrees. We're just going to see, how we can modify it. And then we're going to edit the comment as well. We might as well make the code nice and neat and clean. Although the comment doesn't make any, you can put whatever you like in the comments, it won't make any difference. And here, because I'm modifying it, I'm going to put my name on it. I'm just making a date up. This isn't the actual date. But you notice I'm not deleting Scott Fitzgerald. This is because Scott Fitzgerald has made the majority of the code. If I was to sort of change the majority of it, I might remove that. Or more likely, what I'll probably do is I'll probably put modified from a design by Scott Fitzgerald. So right, that's that then. So what I'll do next is I will verify the code. Always verify the code. Excuse me. And then we will upload the code, and then we will see what happens. Okay, so we just need to plug that in and see what happens. And oh, look at that. So you see now it doesn't go as far. It's going roughly in 90-degree backwards and forwards motion. So yeah, I'm happy with that. I've taken some code that would be useful at the basic level, and then I've modified that code to suit my own needs. And yeah, I think I'm well on my way to being an electronics wizard now. Okay, so again, I'm doing another voiceover, so I do apologise. So before we progress, I just want to address a comment that was made by Chris Campling on my first video. A very good, valid comment. And he asks, sorry, he doesn't ask, he says with the budgeting, it's just like part work, because some parts are not what the magazine is costing, and others have expensive parts like PCBs. And it also it kind of made me giggle because I'm starting to learn the true cost of things like circuit boards and components. But I also had a conversation with somebody, and we were saying that things like plastic components and metal parts, we don't really know what they cost because we've never manufactured them. They could be quite cheap. I suspect they are quite cheap because these part work companies, they're ordering these in bulk, possibly by the millions, definitely by the tens of thousands. But the electrical components, we think they're expensive. I've seen people get very excited about a couple of wires and LED bulb. And wires aren't very expensive, as you'll find out in a little while. And although we're not playing with LEDs in this issue, I recently bought some LED bulbs. I think there was something like 375 bulbs for less than £4, which is ridiculously cheap. It's a penny each. Yeah, if I did a part work and I gave you a couple of wires and some LED bulbs, charge you £7.99 for it, you would probably turn around and go, well, hey, this week we're doing electronics. So what we'll have a look at, we're going to have a look at Arduino, a server, and a couple of jumper wires. I will warn, this is the servo, £3.95. Now that is actually more expensive than I first thought. I didn't I actually bought the a kit, and it had a servo in it, and the kit was about £50, but it had loads of components with it. So say £4, but they're still not too bad. I mean, if you bought them in bulk, if you bought 4 or more, they're a little bit cheaper. But even if you bought 6 of them at that price, that's what my maths is gone. 24 pounds for 6 servos that control the dome tops. Next we'll have the jumper wires, I believe. Now I can't buy 3 jumper wires. The cheapest I could find was a pack of 40, which we should come up on the screen shortly. Also, I'll just have a little word. I use a company called Banggood. Now years ago we used to say Chinese electronics are terrible. They're not good quality. But over the years they have got better, and you'll probably find a lot of things that you buy, it may well say made in the USA, made in the UK, made in this country or the other, but the chances are if it's got electrical components in it, those parts are actually been bought from a company in China, and that's because they are actually quite reasonable parts now. So yeah, I order from Banggood. So here's our jumper wires, £1.32 for 40 wires. And as you can appreciate, if we bought more wires or we just bought cable, this would be a lot cheaper. And next we're going to have a look at the Arduino. We probably only need 1 Arduino to control 6 servos. But obviously, bearing in mind that the servo is £3.95, just have a little guess, see how much you think the Arduino would cost. It's a piece of electrical component, it's got chips and you can program it, it does a hell of a lot, so just have a little think. So there you go, £2.45. Were you as surprised as me on that one? Now you can actually get what's called a Arduino Nano. They don't do quite as much as the Arduino, sorry, the Uno, but they have they're more suited to specific tasks. So they cost about £1 each. You can buy them in packs of 5 or 10. So what I will be investigating is, will an Arduino Nano be suitable for things like the servers? It's just literally an on-off switch. So there you go, Chris Campling. I hope that answers your comment. I'm not going to use the word rip-off, but obviously these companies are out to make a profit. So they need to sell their goods at more money than they bought them for. But I don't know. Sometimes I think you don't get as much as you think. So again, apologies for the voiceover, but that's pretty much all we're going to do this week. Apologies that I've not printed off more things. However, we will finish off we'll print off rings 3 and 4. Oh sorry, no, apologies, that's actually the kit that I bought. That's about £40–50, and that's got lots and lots of components in it. Some we may well use for the R2D2, others we won't. When we come to use the parts, obviously I don't want to abuse the cost of the actual kit, because we're not going to use it all. So I will charge the R2D2 as individual components. So you'll see me waffling away on this, showing off the various components. So you see a remote control, and then obviously what we'll do next is we'll finish the episode with we'll print off 2 more of the body pieces, and then we'll go through the budgeting of what we spent this week. So this is ring section 3 and 4. Usual procedure: printer off at a 0.3 layer height, We're not after the quality because we are going to have to sand, and I believe this will take about 6 hours. Got to apologise, I can't actually read the screen because it's in a small preview screen, but I'm sure it's about 6 hours. Okay, so here are the pieces. This is number 3 and this is number 4, and they will go together like that, and I'm pretty sure you're going to recognise that part. Now these are the bits that I was worried about. I'm trying to find the right. This is how it was on the bed, and you can see there that no supports required. It came out absolutely fine. And on this bit, this is the bit I was a little bit worried about, but again, absolutely perfect. Absolutely no problems there whatsoever. Now we've got some holes here. Now this is going to be the inside, so I assume there's going to be something going in there. That's quite an interesting point. We've got some holes on the top there. I think that's where the next ring is going to attach. And what I'm finding interesting there is that I think this might actually be for a wire, because you see there's a channel there. So I can't remember what's going in there, but I think it's going to be powered by some kind of electronics, which means that this hole there will be possibly to connect the top ring to it. The next ring, I cannot remember. And you can see you've got some locating pegs there. There, and there, and we'll drill those holes out. We'll put some filament in there, and then they will go together like that, and they should line up pretty perfect. Little bit rough, so it will need quite a lot of sanding, but that's fine. I'm ready for that. So that's it. That really is it for this week. So we'll just do our costings. Okay, so we had £3.46 last week. We're adding £10 to it to this week. Now the silver lower ring section 6 and 7, that came to £2.29. Ring 1 pieces 3 and 4, the parts that we've just done for advance, that's £2.79. That brings our total spend to £5.08 for the week. Remember the Arduino and the servos, we're only playing with those just to see what happens, and then that gives us a balance of £8.38, very nearly a full week. Which we'll carry over to next week. Okay, so that's everything completed for this week. Now, in between making this video, I've actually finished dome piece number 1. I've done the complete reprint. You may notice there's a little line going across the middle. What actually happened was I did have some silver filament, but I knew I didn't have enough to do the reprint. So I actually finished off the bit of filament that I had, and then I couldn't get the new filament in quickly enough. I tend to change the filament as it's running, and it just got stuck and it just missed that line. It was solid, but it was just an outside line missing. So just to strengthen it, I just ran the 3D pen along. But that's the beauty of the 3D pen, because otherwise I may actually have gone, I don't like that, I'll reprint it. So there's dome number 1. So next week we will glue this with part 2 and 3. That will give us 2 halves of the dome. I've also reprinted the pies. Now as I'm recording this, obviously I've already filmed me doing these, and I wasn't quite happy with the way they turned out. So off camera I will glue these together. That will bring us up to where they should be, so these will look as they should. So next week we're going to be, I'm just checking my list, and we're going to be starting on the upper ring, which is exciting for me because it's a new colour, so having the contrast of different colours will look nice. As I say, we'll glue 3 pieces of dome together to make 2 halves, and then we will do more of the body. So don't forget to like, share, and subscribe if you haven't already done so. I'm really looking forward to making next week's video, and don't forget that at the end of the what comes next, after the credits, will be the comments in more detail. So those of you that have been generous enough to give up your time just to make a little comment, I like to acknowledge those. I like to go into them in more details, and just thank you personally. So take care, guys. I'll see you next week. Okay, so thank you to everybody who commented on my episode 5 video. P40F20 has said, I was going to recommend to you to put washers under the heads of the bolts, but you beat me to it. You might want to get some Loctite thread locker fluid to keep the nuts from vibrating loose when R2 is all finished and operating. I would not recommend super glue on screw threads. Great update as always, and best of luck as you continue this build. To be honest with you, that's something I completely forgot about, but I think that's absolutely fantastic advice. So that's going into my list. For those that don't know, Loctite thread locker fluid, it's, I don't really know how to describe it, but it's like a glue, but it's not really a glue. You put it onto screw threads, and it actually helps you to put screws on. But once it dries, it kind of grabs the screw head, so that it doesn't come off easily. But if at any point in the future you need to remove the nut and bolt, you can still do that. Love Mini says using glue, bolts and 3D pen should make a great seal for those seams indeed. Chris Campling says great video as always. Penny, cannot wait till it's finished. This is finished, looks amazing. I agree, I can't wait till it's finished. Like all projects, this has got its frustrating bits. For example, in this current issue, current episode, I've run out of filament, so I've got to play with something else. So the trick really is keeping yourself busy. If you've got something you can't do, find something else to do, because if you lose the momentum, it's really hard to get going again. Andy Clift says great work so far, though I am amazed at how calmly you dismiss the print fails. I don't own a 3D printer, but having seen the problems that you are experiencing, I think it's a good thing, as I would have put a sledgehammer to the thing by now. Definitely not going on my Christmas list. I admire your cool just as much as I admire your work. I'll be honest with you, the costs that I've given you on the videos are not the true costs when you take into account the failed prints. I will be making a video at a later date going through the true costs, but yeah, it can get expensive with the failed prints. However, I'm very much a what I control and what I can't control type of person, and by that I mean if a print fails beyond my control, I can either get upset about it, but I can't change it, or I can just go, okay, fine, it's failed, let's get on with it. It is frustrating, but you just got to go for it. Alan Allsop says, great, can't wait to see it once it's done. Well done so far, though. Chris Davies says, great video and love your videos. David Trapp says, another great vid, keep up the great work. Fleetwood J says, great video again, keep up the good work, looking forward to the next video. Duncan Price says, great vid. And Trevor Rodway says, yet another superb build, Penny. Now time to feed and walk my Labrador named Bailey, have my dinner and then settle down to watch another couple of hours of your Routemaster build. What a way to spend a cold wet Wednesday evening. Say hello to Horlicks for me, keep up the work. I certainly will. So yeah, that's it then, guys. Thank you very much for watching and supporting my channel. It really is appreciated. Hopefully I'll see you next week.